What happens when you press the power button on your Apple Silicon Mac?
Ah, the boot process. It's a fascinating journey that involves multiple stages, each carefully designed to protect your system.
All right, walk me through it.
So it all starts with the Secure ROM, a tiny piece of code that's permanently embedded in the Apple Silicon chip.
Okay, so the Secure ROM is like the foundation of the entire boot process.
Exactly. It's the first thing that runs when you turn on your Mac, and it's responsible for verifying the integrity of the next stage, which is the first stage bootloader called iBoot 1.
iBoot 1. Got it. What does this bootloader do?
Well, iBoot 1 is responsible for loading the system-wide firmware, which is essentially the software that makes your Mac's hardware work.
So it's like the conductor of an orchestra, making sure that all the instruments are tuned and ready to play.
A perfect analogy. Once the system-wide firmware is loaded, iBoot 1 hands over control to the second stage bootloader, iBoot 2.
Okay, and what's iBoot 2's role in all of this?
iBoot 2 is the star of the show. It's responsible for loading and validating the operating system kernel.
So it's like the stage manager making sure that the main act gets on stage without a hitch.
Exactly. But before iBoot 2 can load the kernel, it needs to consult something called the Apple device tree.
Apple device tree. Now that sounds interesting. Tell me more.
Well, the Apple device tree is basically a detailed map of your Mac's hardware. It tells the operating system everything it needs to know about the components and their connections and their capabilities.
So it's like a blueprint that guides the operating system through the complex landscape of the hardware.
Precisely. Without the Apple device tree, the operating system would be completely lost.
Wow, that's amazing. So this Apple device tree is crucial for the entire system to function properly.
It is indeed. And it's also one of the areas where running other operating systems like Linux on Apple Silicon can get a bit tricky.
Oh, how so?
Well, you see, Apple uses their own custom format for the device tree, which can be a challenge for other operating systems that are designed to work with the standard format.
It's just like trying to read a map written in a foreign language.
Exactly. The Linux community has been working hard to create tools and drivers that can translate Apple's device tree format, but it's definitely an ongoing effort.
I can imagine.
Yeah.
But hey, that's part of the fun of working with open source systems, right?